So let's have your focus and attention up here. It's great that you guys can say that what the Pythagorean theorem is. I mean, you all just told me a squared plus b squared equals c squared. Some of you maybe don't know what that means. Some of you do. So the Pythagorean theorem obviously has to do with squares, square numbers. And so it's also related to square roots. Okay? But I want you to think about the picture of what's going on in the Pythagorean theorem today for a few minutes. Okay, because what it really says is, if you look back in time historically, there's all these different historical points in time where geometry was used to explain the Pythagorean theorem. And you guys should be able to do this. So Sam, put your pen down or listen or do whatever you need to do. Okay? So what this is really saying is that if you have a right triangle, the Pythagorean theorem is always related to a right triangle. So you want to make sure we're always talking about a right triangle when we talk about the Pythagorean theorem. This statement is true as long as C is the hypotenuse. I'll show you. And these A and B are the legs. So I think, but I can't remember if I set this up. So in a triangle, this is basically, the hypotenuse is the longest side, or the side that's opposite the right angle. The legs are the two sides that form the right angle. Sean, put the calculator away. Let's put the calculators away. Just put the caps on. So it's important that you identify the hypotenuse versus the legs. The legs make the right angle. The hypotenuse is opposite. So in this picture right here, the legs are the two angles, or the two sides that form the right angle. Does that make sense? And this is the hypotenuse here. We okay with that? So what the Pythagorean theorem says, other than a squared plus b squared equals c squared, what that ends up actually turning out to be is there's some geometry involved here. I'm just going to erase that. Turns out that if you take a square and draw it along the side of this right triangle, let's look at that square for a minute. What's the area of that square? What's the area of this? It's 16, right? Okay, so it's 16 units. Okay, and then if we take another square over here and make it the length of this one, it's 9 units, right? So what do you think? If I drew a square there, what should the area of that be? Okay, let's think about what this formula says, because not everybody's used this before. But according to this formula, it's saying that the legs, if you square each leg and add them together, so if I did a squared and then added it to b squared, remembering that the legs are the a's and b's, I would say 3 squared. So I'm really saying the area of a square that would fit on one side, one leg, plus the area of the square that would fit on another leg, that's 4 squared. If I add those up, I have 9 and 16. You see that? You see that? So when I add 9 and 16, I have 25, and 25 then must be equal to c squared. So it's saying if I drew a square over here, it should be an area of Well, an area of 25, but the side length should turn out to be 5. Do you see that? So with the smartboard, let's check it. Let's take a square of side length 5. Is that 4? And then, drop it. Bring that over here. Make this a little bit smaller. Let me clean some of this up. I'm going to take this right here and move it. Just shrink it down for a minute. We could look at that in a minute. And take this, and I'm going to try to stick it in place and see if it fits. And that's, can you see that that lines up? So what the Pythagorean theorem is really saying is the area of a square on the hypotenuse has the exact same area as the sum of the two squares on the legs. It's a geometry problem. So if I did a different picture, like with this one here, this is 1, 2, 3, 4, 5, okay? And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 5 in length. This is 12 in length. By the Pythagorean theorem says a squared plus b squared is equal to c squared. So if I take the leg values and I square 5, and I square what? 12. This is 25, and this is 144. Okay, so 25 plus 144 is 169. You guys know the square root of 169? Remember you were supposed to memorize all the way up? 13, right? Yeah. I almost said 15. So I could check my answer with a picture. So that's 2, 4, 6, 8, 10, 12, 13. This works with every right triangle. If I rotate this, I should be able to stick it up here. Just getting the same angle before I move it. And it should fit. And that works for every single right triangle. Of course, you don't have movable smartboard graph paper at home, but that's kind of where that comes from. So it's useful in a lot of engineering stuff. It's useful in a lot of physics. You do a lot of geometry in engineering and physics. But before you get to applications, a lot of times you need to practice some of these. We're going to look at some sample practice problems, not deep.
Like a squared plus b squared equals a squared. Can you do a squared minus c squared equals b squared?
You could do c squared minus a squared. Can't go the other way. Okay. Because the hypotenuse has to be the biggest number. So this is always the biggest number because think about that this angle right here is the biggest of the three angles in the triangle. So the triangle has to open up widest to get to that side. So types of problems that you would have to do is, can you look at three numbers and decide if they form a right triangle? Emilio? Oh. Can you just look at three numbers and decide if they form a right triangle? You could, because what's the Pythagorean theorem say it has to be true if it's a right triangle? It says this has to be true. This rule has to be true as long as you have a right triangle. And what do you know about C? It's the biggest, right? So you can test the rule because this would have to be C, wouldn't it? Yeah. So you'd have to say that 9 squared plus 12 squared, and you would say, is that equal to 15 squared? And then you would just work it out and see if it's true. So 9 squared is 81, right?
81 plus 144.
Yeah, what is 81 plus 144?
Um, 225, which is
And remember, Matthew said his teacher made him memorize these. This kind of test for him, because he has these memorized, perfect squares to 25 is going to make your life easier. Because guess what? You're not going to get a calculator when you take a test on this. So it's true. He's correct. These are equal. If you don't have them memorized, you have to go through all that work, don't you? You have to think of numbers that multiply to give you 225. Like 25 times 9, right? And then you have to break 25 down and get 5 times 5, and you break 9 down and you get 3 times 3, and then you've got your pairs. So one number for each pair. 3 times 5 makes 15, so it works. But think about how much time you just spent doing this. For he did this in less than a half second. You want to memorize the perfect squares from 1 to 25. You really do. Otherwise, you're going to be taking time away from yourself on the test, time that you could be thinking about other things and not feeling stressed out that you're having to work out tons and tons of problems that the next kid's just memorized. It's one of those things that would be handy. How about 2, 3, and 4? Do those make a right triangle? No, right? Because 2 squared plus 3 squared, that's 4 and 9. That does not equal 16. So here we say no, but here we would say yes. You understand that? And then this last one, what's the hypotenuse if it works? 26. 26 would be, right? So we'd say 10 squared plus 24 squared. So notice these aren't in order this time. You have to think about it. That's 100. What's 24 squared? 525 squared is 625. So you know it's, think about what it's between. 20 squared is 400, right?
416.
5, what'd you say?
176.
576. Okay, so this is 676. Now we have to see if that's 26 squared. It would be easier to square 26 than to break down 576, wouldn't it?
576.
Yeah. And you can always just do the first thing, check the last number. Was 6 times 6 end in a 6?
Yes.
So you have to keep going, right? But if it didn't, you could stop right there and say no. So 26 times 26, using the area model. This is 400, this is 120, this is 120, and this is 36, right? So this is 240, so that's 640, right? Plus 36. Oh, did we? Yeah, 676. Does it work? No? No. 576 plus 100. It does work, right? Okay, so it's a yes. These form a right triangle. Raise your hand if that makes sense. Okay, great. So other things are finding the missing piece. Can you find the third side? Find the other leg.
I know how to do this.
Okay, how would you do that?
49.
Whoa. Was that Johnny?
Yeah.
Okay, how would you do that?
So you would make like you would multiply the hypotenuse of the hypotenuse and the leg that you have times the leg, so it would be 7 times 7 and 14 and 25 times 25.
Let's call this B.
Yeah.
I would draw a picture and then do what he's saying.
Do like the square.
So remember I'm just catching up with what you're saying there. So he's saying you would do 7 times 7, so that's 7 squared, right? We don't know B because we're looking for one of the other legs, but we do know the hypotenuse is 25.
I know that 7 is that's the 7th leg.
How do I know what?
That 7, that's the letter.
It doesn't matter if you have the 7 over here and you call this A. Oh, that's weird. Okay, so you could call this B or A. It just doesn't matter as long as they're legs. Right? What matters is the 25 stands alone. Okay.
So it would end up to be 25 times 25, 625.
Right.
And that's 7 times 7.
49.
42.
49.
49. And then you subtract 49.
Right. Subtract 49. So, like when I do that, if I had subtracted 50, you'd have 575, wouldn't you? I subtracted 1 less. 576, right?
And then you find the square root.
Then you have to find the square root. Okay, but here's the thing. If it's a perfect square, remember, and you don't have them memorized, remember it's something times itself that has to end in a 6, right? And 20 times 20 is 400, right? And 25 squared is 625. So there's only a few choices in between. It's got to be one of the numbers in between if it's an exact square root. Do you get that? So 21 would end in a 1, wouldn't it?
Yeah.
If you did 21 squared, it would end in a 1. 22 squared would end in a 4. 23 squared would end in a 9. 24 squared
6.
would end in a 6. So if it's a perfect square, it's got to be 24 squared. So check that. Don't go through all of them. That's craziness.
That would take so long.
So do 24 times 24. I'd like to use that area model because it's visual for me. 400. This is 80, right? 80 and 16. What are 80 and 80? Add a 16. 176 out of 400.
576.
So B is,
576.
no, B squared is 576. Take the square root of both sides. B is 24. Do you see how I'm not doing every possibility? I'm being smart and picking the only one that might work. And then if it didn't work, I would just do an estimate to the decimal place.
What if you memorize the estimate?
Well, that would be super easy to take a test if you have it memorized up to 30. But up to 25 is pretty useful. Okay. Let's see if I had anything else. Oh, that's answers to tonight's homework. Okay. So that's it for today. There are some applications, but if you start with the basics in the homework, the beginning of the homework, this should get you through it, and then, you can always look at some samples in the book for some of the applications, because I'd like you to spend about 10 minutes in class starting this. And just stop this.